All right, this is Mr. Gillum, and today we're going to learn about equations of proportional relationships. So we talked about what proportionality was yesterday, as far as it has to increase at a constant rate, and it has to kind of trend towards zero as well. But today we're actually going to learn about an equation that a proportional relationship has. And what we're going to find out about is that it must be linear, but we're going to discover that here in just a second. So, proportional relationship sometimes is referred to as a direct variation. And a direct variation has a special type of equation. We call it y equals kx. And eventually, someday, we're going to learn about y equals kx as being a linear equation because it increases the same amount every single unit that goes by. And that's why it relates to a unit rate. So when we are doing a direct variation equation, it must be a proportional relationship. If it's not proportional, we can't use a direct variation equation. This is going to be very important because what we're going to do is we're going to actually have to find the constant of variation. And basically what that means is for each unit that goes by, that's how much it increases by. Okay? That's how much it increases by. So we need the constant of variation, or the constant of proportionality, you might hear it called that, to find the equation y equals kx, where k will be the only number in our equation. The y and the x will stay as variables because they will represent different things in each problem. So let's take a look here. And it seems like a lot to take in, but when we're trying to find our constant of variation, there's a specific way we need to find it. I circled it on the last slide, but it's very important that we know that the constant of variation, the constant of proportionality, is the y's over the x's. Okay, it's the y values divided by the x values. Specifically, it'll be, let's see here, how was I going to say that? We could call it y2 minus y1, and those are just sub numbers. That just keeps our y's separate from one another, over x2 minus x1. All right, and those 1s and 2s, those are not y times 2 and y times 1. Those just are numbers to keep the y's separate. And I'm going to show you where they come from here in just a second. But the important thing is going to be this, more so than that equation. Our dependent variable which is also kind of a long word, will be divided by our independent variable. A lot of times our independent variable will actually be time. And we consider it to be independent because it always increases at the same pace no matter what. It always goes on. It always continues at the same rate. Nothing ever changes about it. It is independent of everything else that's going on. Whether I eat chicken for dinner or I eat salmon for dinner, it doesn't matter because time will go on no matter what I'm eating and it will never change. So my independent variable will always go on the bottom while I'm trying to find my constant of variation or my constant of proportionality. All right, and that's going to be a little more clear once we start doing some problems. Determine if the relationship shown in the table is proportional. If it is, write an equation representing the relationship. Now we did things very, very similar to this yesterday, except for the chart looked a little different. It said hours on the top right here, and it looks sideways instead, and miles on the bottom. All right, but really it's the same chart after 1 hour, 2 hours, 3 hours. And we practice this to decide whether or not something is proportional or not. And this time 165, 2 130, and 3 195. All right. So what we actually want here is an equation that represents this. Now I'm going to tell you right now, they're all proportional. Well, they might not all be proportional. We need to check to see if they're proportional. And the way we do that is this. We compare the y values and the x values. So 65 to 1, x, y. And like I said, the time is almost always the independent variable. The independent variable, the time. So the x values go with the time, and it's y over x. The independent variable goes on the bottom. So there's one of our fractions, and then we have 130 divided by 2, and then 195 divided by 3. Now, I notice a trend going that 3, 2, 1, 0 would be the next one. And I also notice a trend, 65 plus 65 would be 130, plus 65 would be 195. Every time it's going up 65 each time. So if I wanted to find where 0 would be, if I keep subtracting 65 each time as I go down, it would be at 0. So it does trend towards 0, 0. So yes, I could say that A, proportional. It's definitely proportional. Okay, A is definitely proportional. But I want an equation. And when it says equation, I'm thinking y equals kx. All right, so this is going to be really new for us. Because I get the same ratio every time, 65, when I reduce these fractions, that never changes. It is constant. So that's what we call the constant of proportionality. That's the amount it changes per unit, which is a unit rate, which we've also been talking about. So my k value, in this case, is going to be 65. Once I know my k value, all I have to do is put it in my equation. So my equation, because it does say to write an equation, for part A will be y equals 65x. And that's it. That is a direct variation equation, a proportional relationship. And I knew this. This guy right here is called my constant of variation. And it's just how much it is constantly increasing. But you can only write the equation if it is a proportional relationship. So let's look at part B here. Once again, if you want to think of the table like we did yesterday and draw it sideways, you can if you want. This is pounds and this is cost. And now it's a little harder to tell where the independent variable is this time. But the way that I remember it is that the amount of cost depends on how much it weighs. So if I have the independent on the bottom and the dependent on the top, the cost depends on how much it weighs. So the cost is definitely going to have to go on the top this time, and the pounds on the bottom. That's what I'm thinking as I'm looking at this. But I can draw my chart here. Pounds is 3, 6, or 9. And then 2.25, 4.5, and 6.75. And that's just the same exact chart as this. I just rewrote it sideways because that's what we did last time. So when I look at the ratios here, I'm going to say 2.25 over 3, 4.5 over 6, and 6.75 over 9. Now, let me just show you if I can figure out how to move the screen down a little bit. Let me see here. How could I do that? Maybe I can't do that. Well, let me just show you a trick up here in the margin then. If I want to reduce 2.25 over 3, and I got a decimal up there, kind of like when you reduce a fraction, you divide. If I want to change that out of decimals, I'm going to multiply the top and bottom by 100. So I have 225 over 300. Now I can reduce it. I know 25 goes into 225 9 times, and 300 12 times, which is 3/4, because 3 goes into 9 3 times and into 12 4 times. So 2.25 over 3, believe it or not, is really 3/4. So 3/4 for this first one. And 4.5 over 6. I'm going to do the same trick again. But really, I'm just going to multiply it by 10 this time, because I just want to move it one decimal place. 45 over 60, which is 15 goes into both of those. 3/4 again. 15 goes into 45 3 times, into 64 times. So that's 3/4. So we just need to make sure that 6.75 and 9 are the same way. I'm going to multiply by 100 this time. 675 divided by 900. Well, let's see here. What number goes into both of those? I'm going to say 25. 25 goes into 675 27 times, and into 900, how many times? 36 times. And I see that 9 goes into 27 and 36 3 times and 4 times. So yes, we do have the same change every time, which means it's proportional. That change itself is called the constant of proportionality, or the constant of variation. That's how much it changes every time. So for part B, now that I know it changes the same amount each time, and it's going to trend towards 0, if I keep going down and down and down, it'll get towards 0, 0. I can say my relationship is y equals 3/4 x, and that's it. All right, and so that's my equation. It is definitely proportional, so I can write my equation. Finally, let's look at this last one here, and I'm not going to make it a sideways table this time, but I'm going to tell you these are the x's and these are the y's. The number of miles depends on the number of hours. So we want dependent over independent. Dependent, independent. Time goes on no matter what, but miles depends how far you go, depends on how many hours you go. So let's just take a look here. So I'm going to do y over x, 3 over 1/2. Oh, we've been practicing these. 4.5 over 3/4. And 9 over 1 1/2. Now hopefully these are proportional. 3 divided by 1/2 is really 3 over 1 times 2 over 1, 6. And I'm going to change this guy. 4.5 is really 2 times 4 plus 1, 9/2 divided by 3/4, or 9/2 times 4/3, which is 36 over 6. 36 divided by 6 is 6 as well. And I hope that 9 divided by 1 1/2 is 6. 9 divided by, and I'm going to say 2 times 1 plus 1 is 3/2. 9 over 1 times 2 over 3 is 18 over 3, which is 6 again. So I got 6 for all three of them. So once again, I have a proportional relationship with a constant of proportionality of 6. So I will say y equals 6x, and that's my equation. All right, so given the table, you should now not only be able to tell whether it's proportional or not, but write the equation of a proportional relationship. Now let's do a little word problem here. I know we love word problems. This one says 2 pounds of cashews cost $5. 3 pounds cost $7.50, and 8 pounds cost $20. So let's just do this. We'll do the pounds and the cost. Okay, the pounds and the cost. The pounds are 2 for $5, 2 for 5, 3 for $7.50, and 8 for $20. Ooh, there's a big jump there. Okay, it says show that the relationship between the number of pounds and the cost is a proportional relationship. Then write an equation that you could use to find the cost of 10 pounds of cashews. Now, the cost depends on number of pounds. The cost depends on the number of pounds. So we're going to say this guy is my independent right here. And so we're going to do independent divided by dependent. I think. Let's make sure on that. Dependent divided by independent. That's what we want to do. Dependent cost 5 divided by independent 2. 750 divided by 3. 20 divided by 8. Now hopefully this is a proportional relationship. it says show that they are proportional. Well, to show that, we're going to say these have to be the same. So 5 halves. I'm going to do that little trick again. I'm going to times 7.50 over 3 times 100. 750 over 300. And I know 50 goes into those numbers. 50 goes into 750 how many times? Let's see here. 15 times. And 15 and 6 both reduce to 5 over 2. And 28ths. I know that 4 goes into both of those. 5 over 2. So looky there. I got 5 over 2, 5 over 2, 5 over 2. It must be proportional because it does look like it's going towards 0 or trending towards 0. So yes, it is proportional. My equation is y equals 5 halves x. But there's another question here. It says, write the equation and find the cost of 10 pounds. Well, the pounds were my x variable, right? My independent variable. So what I'm going to do is I'm going to put in 10 right here, and I'm going to figure out what it would be for x. So I'm going to say y equals 5 halves times 10, or y equals 5 halves times 10 over 1, which equals 50 over 2, which equals $25 for 10 pounds of cashews. And would that make sense in this context? Yeah, that looks like it would make sense. So I'm glad that we checked that. Okay, so a lot of work on some of these problems. Last but not least, Jeremy is saving money from a tutoring job. After the first 3 weeks, he saved $135. Assume it is proportional. Okay, so we already know it's proportional. And after 3 weeks, this is the time, he has saved cost, or money we should say, $135. Write an equation relating the amount saved to the number of weeks worked. At this rate, how much will Jeremy save after 8 weeks? Okay, let's take a look here. This time my independent variable, the one that never changes time, but the dependent variable is cost. It depends how much money he saves, depending on how long he's working. Okay, so since we know it's proportional, we just really need to find, this is the independent, we need to find 135 divided by 3. And we got to see what it is. Let's see here, how many times? I'm going to say 45. There's my constant of proportionality, because the only reason I know that is because it says that it's proportional. So I know for sure y equals 45x. All right, so there's my equation. We wrote our equation. At this rate, how much will he save after 8 weeks? Well, I need to plug in 8 for my weeks, and I want to know how much he saved. So time is my independent variable. Y equals 45 times 8. Ooh, big number. Y equals $360 bills, y'all. That's how much money he can save at 8 weeks. Okay, so confusing things to remember are the dependent variable is divided by the independent variable. And you have to use your noggin to kind of remember which one is which. Okay, in this case, the amount that he can save depends on time. Okay, on this one, the amount of flour depends on the number of servings. On this one, the number, or the cost depends on how many pounds. So that's how you tell what the dependent variable is. Once you have that guy, we call him K. That is the constant of proportionality, or constant of variation. And we plug him into this equation here. And then we can predict, if we know how long or how much or whatever we're doing, we can plug in whatever number we want, because we know it'll increase at this rate no matter what. And that's it for today.